All right, so this video is going to go over 3 short examples of calculating percent by volume or percent volume over volume of solutions when we're talking about the concentration of a solution. So example 1 says, what is the percent by volume of ethanol in solution that contains 27 milliliters of ethanol dissolved in 139 milliliters of water? So when we're looking at this question, the important thing to note here is that it gives us our information about water and about ethanol. And we want to know what is the percent by volume. So that's my unknown. Percent volume over volume is volume of solute divided by volume of solution, so the total volume, times 100. The volume needs to have the same unit of measure between the two volumes here. Luckily for us in this question, we have milliliters and milliliters. Now, on the left side, what we were given is a volume, not the left side, at the here in the question, the first part that it gives me is 27 milliliters of ethanol, and it tells me 139 milliliters of water. Now, when I compare these two to determine which is my solute and which is my solvent, solute is always what I have less of. It's what I'm dissolving into what I have more of. So my solute is ethanol. So that's the number that's going to go on top. So the percent volume over volume, or percent by volume, is going to equal the volume of ethanol over the volume of water plus the volume of ethanol. So the volume of solution, so total volume times 100. So I need to know my total volume. 27 milliliters plus 139 milliliters. So when I add these two together, I should get 168 milliliters of solution. So that's my overall total volume. Milliliters over milliliters times 100. So 27 milliliters divided by 168 milliliters. Now the first one was milliliters of ethanol. I like to write that in there so I know what I'm solving for. Times 100 is equal to, so I get my calculator out, and I have 27 divided by 168, and then I multiply that by 100. So my decimal moves over to the right 2 spots. 16.07% ethanol. Now, when I'm looking at this, I go back to determine how many decimal places I need by looking at my significant figures. I have in my given 27 and I have 168. I go with whatever I have less significant figures of when I solve this. So 3 significant figures for 168 and 2 for 27. So my answer needs to be to 2 significant figures if I'm answering to the proper number of significant figures. So I round to 2 significant figures, so I'm going to have 16% ethanol. Our next one reads, what is the percent by volume of a solution that contains 35 milliliters of nitric acid in 1.5 liters of water? So in this one, it's giving us 2 different units of measure. So let's start off, what are we identifying? We're finding the percent by volume. So that's my unknown. I know from my calculation that percent by volume is going to equal volume of solute over volume of solution times 100. The important thing, though, is that both of my units of measure are the same. In this case, that's not the case, so I need to change one of them. So I could change liters to milliliters, or I could change milliliters to liters. Either way, it'll work out the same way in the long run. So if I were to change liters to milliliters, then I would take my 1.5 liters of H2O, because that's what it says, of water, and I would convert that using my conversion factors that I know. Well, I know that according to SI units, that if I have 1 liter, I have 1,000 milliliters. So I take this number and I multiply it by 1,000 to get what I need. So 1.5 times 1,000 means I'm going to move my decimal over to the right 3 spots. So I have 1,500 milliliters of H2O. This is my solvent. So that's not my total volume, that's my solvent volume. So I'm still going to have to add it to the 35 milliliters of nitric acid. So I take my 35 milliliters and I add to it the 1,500 milliliters. So my solution is the total. And that is 1,535 milliliters. Oop, I wrote that twice. Sorry about that. So 1,535 milliliters of solution. So my solute hasn't changed. It's still nitric acid. My total volume of solution is there. So now I go through and I calculate by putting everything where it needs to go. So percent V over V is equal to solute, 35 milliliters of HNO3, nitric acid. Divide that by the total, 1,535 milliliters of solution times 100. So, get that handy calculator out, 35 divided by 1,535. Then I'm going to multiply by 100 to move the decimal over, and it gives me 2.28, or in this case, to 2 significant figures, so 2.3% HNO3. For my third and final example here, I've got if 22 milliliters of cyclohexane is used to make a 15% by volume solution of cyclohexane in carbon tetrachloride, CCl4, how many milliliters of CCl4 were used? So in this one, my solvent is a different solvent than what I've been using, but it doesn't make a difference in how I go about solving my problem. So I don't need to know what the components are to be able to do the math. Is it nice to know that stuff? Yeah, but you don't have to know it to do the math for it. So we take our equation and we work from there. So our equation is that percent by volume is equal to the volume of solute over volume of solution times 100. So let's identify what we know and what we need. So 22 milliliters of cyclohexane is used. And it tells me that it's a solution of cyclohexane in CCl4. So that means CCl4 is my solvent. And cyclohexane is my solute. Now that I know that, I know that my 22 milliliters of cyclohexane is my solute volume. and then it gives me my percent by volume, percent V over V. So if I check off what I know and what I don't know, I know volume of solute. I know percent by volume. I don't know the volume of solution. And CCl4 is not the solution, it's just the solvent. So that means I also don't know the volume, milliliters, of CCl4. This answer here, the CCl4, is not the same as your answer to the volume of solution, but I have to have the volume of solution to identify that. So let's begin. We'll start off with taking our units and putting everything together. So 15% is equal to volume of solute, 22 milliliters, over volume of solution. I don't know that, so I'm going to replace that with a variable, x, milliliters, times 100. So I'm solving for x. So first things first, let's go ahead and divide both sides by 100. So now I've canceled out the 100. 15 over 100 is 0.15. And then I'm going to take that and set it equal to what's remaining, 22 milliliters over x. Now I need to solve for x, so I'm going to now take x and multiply both sides by x. The reason I do this is so that my x is in the numerator. So I now have canceled out x on the right side, and I have 0.15x equals 22 milliliters. So now I'm going to take my 0.15 and cancel that out on the left and divide by 0.15 on the right. So now I have x is equal to 22 milliliters divided by 0.15, which is equal to 22 over 0.15, 146.67, so 146.67 milliliters of solution. Okay, so we go back to our problem, and it's not asking us for the volume of solution. It wants to know how many milliliters of CCl4. Okay, so to determine that, I take my starting volume of my solute. So solute from solution. So let me write this again. So solution volume, so milliliters of solution minus milliliters of solute, will give us the milliliters of solvent that were present. So that means if I rewrite this, I have the 146.67 milliliters of solution minus 22 milliliters of solute. So that gives me 124.67, and we were only really given two significant figures. So this is going to be 120 milliliters, or if you want to be a little more precise, if your teacher's okay with it, then you would be able to put 125 milliliters. You could also write it in scientific notation. 1.2 times 10 to the 2 to the second milliliters. And all of these are in the form of milliliters of CCl4. So any of these are technically the answer, but really the most acceptable ones are going to be the 120 or the 1.2 times 10 to the second. And those are your examples for percent by volume.